All right. Well, cheers, Ariel. We're back. We missed last week, but we're back. A good one today. Pints with Ayre. What is today? 8/18. August 18th.
Right. Kids are back in school. It's yeah, summer's gone.
Yeah, like that. Yeah, my son was bugging me about trying to get a summer job, and summer's already over. So I don't know how anyone has time to find a summer job anymore with how fast it goes. And yeah, last week was a lot of fun though. We didn't have our episode because we were kind of putting some finishing touches on some of our listening spaces and trying to get our factory ready to go to have a bunch of guests over.
You don't see the clutter around me quite so much as you've probably seen in previous episodes because yeah, I cleaned out my office. I'll call it temporarily clean.
And that is officially the wall of beer back there. That's not clutter. That's
yes. That is the collection of the Pints with Ayre beers we've gone through. I'm only missing one or two. But.
Yeah, that's all. That's a premeditated clutter back there. Yeah, it feels great though. I mean, we had like 22, 23 people, I think, here on the weekend, and we had 2 listening rooms going. We kind of kicked it off with like a little just kind of mingle meet and greet session, and just kind of went around and got to kind of chat one at a time with some of the people that came by, and then we rolled right into doing a tour of the factory. That took a little longer than I think we were expecting because there was just so many questions. I mean, when you got a group of audio files together, you know, one question can start feeding off of another, and it was a lot of fun. So yeah, it
was great.
Yeah, we had our Vandersteen Quattros going in our back listening room with mostly 8 series stuff hooked up in the back there. So our new KX8 and the VX8, we went and put that high pass amp mod on the VX8 before the event to do it right. I think that sounded awesome. And then we busted out a pair of Charlie's old Avalons.
Yep, Avalon Ascents.
Ascent. That was the model. I could, because on the website it looks like they've kind of started calling them precision monitor or something different. They're like, it's like kind of that same cabinet design, but
well, yeah, I didn't think they made the Ascent for many years. I don't think it was a long-lived model necessarily, so I don't think they made it for a long time.
Yeah, I guess the cabinets on the precision monitors that are in current production are similar, but they're different driver configurations and such. It's all
but yeah, they probably don't have the external crossover, right?
Yeah, and I was going to comment on that. That is one of my favorite aspects of that speaker. I thought that was so cool to when I first got exposed to those things with the big monolithic crossover housing that sits behind the speaker. But it's quite ingenious. I mean, if you think about all of the potential microphonics that could happen from that movement inside of the speaker. Yep. But go ahead.
No, that's part of it. Yeah, for sure. As well as taking up volume, and yeah.
Well, they impressed. I mean, you know, for the age that the speakers were, and for, you know, kind of sitting in storage more or less for a few years. I mean, they sounded pretty amazing right out of the gate with the setup that we had, and we just kind of let them warm up for the rest of the night before the event, and it sounded fantastic. Yeah, the people that attended got to hear some pretty special sneak peek things that maybe we'll just kind of keep to ourselves for now, still maybe.
Yeah, for now.
But yeah, if you're local and you have a chance to stop by and you've got tight lips and good ears, you might have an opportunity to hear some new stuff in development. But yeah, it was a blast. Glad we did that. And we had Marjorie here, Rocky Mountain Audio Fest. Marjorie Baumert here, and she's a big, influential mover and shaker in the Colorado audiophile scene still.
Yep.
So yeah, I thought, do you want to talk about what we're drinking today? Do you have the can handy?
I do. So again, we're sticking with Avery as per your theme. So we've got one of their Hop Freaks exploration series. This is Majestic Voyage, and it's an Imperial IPA. So it's a strong one. Again, it's for an IPA. It's pretty good. Again, for me, I'm not an IPA fan, but this is another one where I think they're growing on me over time. I keep forcing them down. I'm starting to enjoy them.
It's working. If I just keep buying them, you'll eventually.
Yeah, I won't turn them down. This one might be a little strong for my taste as far as both the the ABV, but it's not crazy bitter or dank. So this is a good one.
Yeah, it's so new. It's not even on their website yet. I
Oh.
couldn't find it at least, and when I talked to our friend at our local watering hole supply, I guess he said that they just got it a couple days ago. So yeah, we're really early on this one. I didn't know that this one was coming out. So it tastes great. It's good for me. Little tarter and fruitier than I might want for a typical IPA, but it's strong. 9.2. Well, that's the beer. Our friends.
Beer.
And we had a couple months ago, we had one of our viewers ask if we could go over volume control, more specifically the differences between digital and analog volume control. And I thought tonight could be kind of a fun opportunity to talk about that. I mean, there's digital volume control, there's analog volume control, there's attenuation, there's variable gain, there's a few ways that we can kind of go about doing it. But
Yeah.
would it be safe to start off by talking about like signal to noise ratio, or do you have a better idea of where to start on how to?
Well, yeah, let's not necessarily start there. I mean, so I mean, there's pros and cons to both. And so I'll start off by saying that digital is much easier and simpler to implement. And so it can be done reasonably well, pretty easily, with a caveat that you are reducing the digital resolution, and there's no real getting around that. That only really comes into play if the subsequent analog sections are if they have enough resolution, if there's enough signal noise ratio in the subsequent analog section, that reduction in digital resolution is actually going to matter or not. So that's the simplified version of the digital. Analog, if done right, is almost universally going to be better, but it's difficult to do an analog volume control right. It's not a trivial thing, and to do it right is difficult, expensive, and so I can see why a lot of companies have either they either go to digital volume control or like some of these digital volume control chips, not digital volume control chips that are digitally controlled, but they're still done in the analog domain. But they're essentially using resistors built into the silicon of an IC, which are not quality resistors. And so And when we're talking about, like a preamp stage, that's why the volume control is probably arguably the most critical component or the most critical stage of a stereo system. It's going to make or break the entire chain. So now we have done both in various products. So like for instance, our first foray into the digital volume control, I believe, with the codecs, as well as I'm starting with the codecs, and so there are some tricks that I don't want to give away too much, but I'll say that the right way to do digital volume control, or given the tools you have, is to do it as part of the upsampling process, and such that the part I'll give away is that as you are essentially oversampling, and you are essentially, what happens is that you essentially spread the amount of noise that you had in the original digitized signal, and then you spread it over a much broader spectrum. And so the level, kind of essentially analogous to just area, just the two dimensional area. And so if you have a certain amount of noise, and the width is the bandwidth, and if you increase the bandwidth, it skinnies down, and so the noise goes down. And so that's part of the trick of basically how you can get away with limiting your loss of resolution with a digital volume control, as long as you build that into oversampling. And so that's what we do in our products that employ or have the option of oversampling, which is those are all DAC products, right? The codecs or the QX5 or the QX8. That is the method we use. And so I believe, running the math, we are able to maintain at least 16-bit, so CD quality, down to minus 60 dB of attenuation, which 60 dB is the typical, typical lowest setting of most volume controls. If you use any kind of pot or any other method, that is typically range 0 to minus 60. And so that's effectively that was good enough for us to be willing to be able to accept a digital volume control. So that's how to do digital volume right. One of the other benefits of digital volume control that is that you don't have some of the other kind of quirks you have to deal with an analog volume control, such as depending on the topology of an analog volume control, you might have varying input impedance or output impedance when combined with some parasitic capacitance, might mean you have different frequency response at different volume levels. Yeah, which is, I know that used to be measured times, a few decades ago. That I believe that there used to be a more common problem, and so some of the magazines would actually measure that, highlight that. So with digital volume control, you don't have that phenomena at all. So that's nice to not have to deal with that. So to do the ultimate volume control, it is to do it analog. And so as we've talked about before, when we specifically talked about our variable gain technology volume control, the more traditional method and what most preamps use is essentially an input attenuator. So where you are, again, scaling the input signal down before the gain stage. And again, the main, the one of the consequences of that is that the gain stage has fixed noise. And if you're reducing the signal, you are now reducing your signal noise. And so when you look at the spec of a preamplifier, and it gives a signal to noise ratio, that's measured at maximum volume, which you are almost never listening anywhere near maximum volume. So if you're listening at, let's say, minus 30-ish dB, the signal noise ratio in that situation is 30 dB less than what that spec is. So if it's 100-ish dB signal noise, which is pretty good, when you're actually using it, it's more like 70 dB signal noise. So one of the huge benefits of our variable gain is it has virtually constant signal noise from maximum volume to minimum volume, because that variable gain affects both the signal and the noise. So again, let's see. So the analog control, old school and traditional, still many preamplifiers use, including our EX8 and the upcoming KX8, use a linear potentiometer. And so there's a kind of either a carbon or some other resistor material is laid or sputtered onto a kind of a rotary plate. And there's a wiper that you then that you manage control, and so its physical position on that resistive track, you basically create this resistive divider. And so that relies on the quality of that resistive element, requires on that physical contact between the wiper and that resistive track. And one of the kind of consequences of that is that those are known to kind of wear out with that wiper, again, with that mechanical wear, and sometimes they get scratchy or something like that. They also do not track channel to channel particularly well, because it's really hard to control on a very fine level the actual resistive taper of each track. And so if you're doing stereo and you have one track on one gang, as they call it, and another track on another gang, it's really hard to guarantee, particularly at low level, the matching between the two channels. And so for us, when we're doing not only stereo but also balanced, now we have basically 4 tracks that need to track pretty well. And so so that was a hurdle for us when we were developing the EX8, and we found some tricks as far as matching and tweaking those to get that to an acceptable level for us in the EX8. So that's kind of the old school traditional method, and it's still used by many let's say most preamplifier manufacturers that aren't using a volume control IC. So then the other, kind of the step up, it probably was, that you saw in the beginning of kind of high-end audio is the stepped attenuator. And so if you look at our K1 or K3, you see a stepped attenuator. And so it's a big step up in quality, because the switching element is now a very high quality, in our case, the Shalco switch company, silver on silver contact switching element. And so then we put basically a resistive ladder. There's just basically a series of resistors, and then the switch taps off a point of that ladder. So that's a pretty typical and commonly used stepped attenuator. And again, that's used very similar to the volume potentiometer that's placed at the input of the preamplifier, and that does not fix the signal to noise problem, but it is a big step up in quality because again, you don't have that wiper now scraping against the resistive element itself. You have a very reliable and durable contact point, but there's very discrete volume positions now instead of the virtually infinite positioning of the pot. You have very discrete points, and there's no in between of those each individual resistors. And so that allows you to use, again, the much higher quality switching element as well as a much higher quality resistor. And so now it's the quality of that signal is then very dependent on the resistor you use. So which is a good thing.
Yeah.
And then again, the rest of it still then depends on your amplification circuit after that. And then, like we talked about, the ultimate solution is our variable gain technology, where we still use that same mechanical, the mechanical function of the rotary switch selecting, basically tapping off a point of that resistor ladder, but we move that to within the gain stage instead of beforehand. So those are the big differences between the digital and the analog. I think I've forgotten a couple things,
well, on our digital volume control, or the products that we have that have digital volume control right now, would be Codex, QX8, QX5. I guess that's really it.
I believe that's it.
Yeah. And so over the preamps, I guess one thing that's kind of maybe not necessarily an advantage, but kind of a neat difference to take in between the two is that on the digital side, we break it down to 100 steps, as we can see here.
Yes, it's much easier to then have as many steps as you want, as fine as steps as you want. It gives you a lot of flexibility that way. Whereas the step attenuator, either the attenuator or the variable gain, you are limited to the size of the switch that you are willing to design in and buy, and yes, it just gets more complicated trying to add more and more steps. And so like the KXR has a 60 position, KX5 has 46 positions. Yes.
Yeah, and then so the combination of this 100 steps with the oversampling, that almost makes the noise problem non-existent for as far as like a digital volume control, I would imagine, because you've got kind of that the oversampling kind of spreads that noise out across the whole spectrum, and then you've got those 1 dB increments. So I'm sure that those two work together to provide a better digital volume control.
Yeah, it's not so much the number or the range of steps. It is simply a factor of the incoming sample rate to the outgoing sample rate. Although it's really more just the outgoing sample rate. So any of that noise coming in is basically spread over the sample rate that we send to the DAC chip, which in this case is 16x. And so essentially the noise is spread out over 16x the original bandwidth.
Yeah. So it's probably it's probably safe to say that, like if you're going digital, if you could run your DAC wide open 100%, that would probably be the most pure way of going about.
It absolutely is. Yes, that is the best way to do it. At a cost,
right? Your ears.
But ears. I mean, it's mostly a monetary cost in this case.
Yeah, most certainly. Well, yeah. So you're going to probably get ideal performance running your DAC fully open, wide open, 100%. And so then that's when it gets to the preamplifier, where the preamplifier's job is essentially to disappear, is to try to get out of the way, and so you don't really want to hear the preamp. And then if you've got your volume on the DAC maxed out, chances are you're going to have to turn the volume on the DAC or on the preamp down to kind of make up for that.
Yeah.
So if you're doing that, you're increasing your noise floor, and so that's where the variable gain technology comes into play. Is it's going to get you closer to that wide open DAC sound at any volume that you want to be at. That's cool.
Yeah, it's awesome.
Oh, this is new. I haven't tried this yet. Look at I found a video. I don't know if you can actually see the.
Actually, see the pulleys moving, but
Yeah, first time getting a moving video background going. Oh, that's cool, and it'll just loop, so we could just sit here and talk while it's just going back and forth. That's awesome.
You can't hear it chunk, chunk. Which again is another benefit of digital. Well, it's a difference between our analog volume controls and the digital controls, is that the digital control is mechanically silent, and so one of the the features of our higher end analog volume controls are the stepper motor noise, and some people love it, some people don't love it as much. It is unique. It's working. And that was even one of the changes we made from the KXR to the KXR20, was not just in the analog circuit, which was a huge deal. We excuse me. We actually tried to address some of that mechanical noise, and so we changed the way that we drove the stepper motors a little bit. We used a different driver chip, and it was called micro stepping, and so it changed the nature of the noise. It still made it still makes a a very distinctive mechanical noise, but it was less sharp and clunky. It was a bit smoother, and it was fairly well received. But that was kind of like a benefit that we haven't really talked about very much, or talked about hardly at all. I think when we first released it, we might have talked about that, but I don't remember now.
Yeah,
so that is a surprisingly significant change. Again, it doesn't affect the sound quality at all. If you're listening, you're not using the stepper motors. When it does move, there is a distinctly different mechanical thump or kind of hum as it physically moves that rotary switch.
You could probably hear that pretty good from regular KXR to KXR20 then, huh?
Yes, it is a significant difference. Yeah.
I don't know what it is. Something about the sound kind of coming through that billet chassis is just really pleasing to me. I don't know. It's just I love it. I think it's really cool, and I can really picture kind of the mechanism at play and what's going on, and so it kind of gives me that maybe added appreciation for it. But
right. Yeah. And then I'd be remiss if I didn't kind of point out the kind of hybrid method we've used in some of our prior products, like the AX7 and K5, that used, again, solid state switches in more of our kind of stepped attenuator as well as variable gain topologies, so that it wasn't a mechanical switch tapping off that resistor ladder. It was a silent CMOS switch making that change, and which is within certain constraints like voltage rails and as well as impedances, that works pretty well. If you're trying to do higher voltage rails, then the CMOS switches are harder to find parts that will support that. But that's just one of the things. Yeah, so we've done pretty much the entire gamut, both from digital digital, kind of the hybrid, CMOS switch, mechanical, step attenuators, and then our variable gain. The only thing we've never used are the volume control ICs. And we have tested a few, and that kind of hybrid approach, because they still operate in the analog domain, but the resistive element quality of those, because they're just silicon resistors, basically made in the semiconductor process, they are pretty awful. So they are pretty much the bottom of our list, and we have not used that.
And I could probably go back and re-watch our awesome AX7 episode to refresh my memory, but did we use something different in that even, or was that a passive just a passive attenuator?
That was yeah. So that was a hybrid kind of a mix, and so there was a coarse 6 dB steps pre-attenuator before the gain stage, and then we had 6 1 dB steps that was a fine variable gain. So that's how we got to the 66 dB. So we have basically 11 coarse 6 dB steps. That was kind of the traditional method.
Mm-hmm.
And then the fine steps as just as variable gain.
Very cool. See, just another volume control. And I guess there is total like passive attenuation too, right? I mean, theoretically, you can probably just like go out of a DAC and run it into like just a passive attenuator, maybe even, right? Just
yeah. And there are, they used to be a bit more common. I haven't seen many of these, but essentially a passive preamp. And so, yeah, which is essentially just either it's typically a source select and then that passive attenuator. And so what it gets rid of is that active stage, which you think would be good, but in my experience is that with that you lose the benefit of the low impedance output of the buffer stage, essentially buffer or gain stage. And so one of the huge benefits of having a active preamplifier is that you have better impedance, necessarily matching, but a better impedance ratio from that to the power amplifier. And so and there's even something about, even in our experience, and it almost seems like even when we trying to run our DACs directly into a power amplifier using the digital volume control, there's always seems to be some benefit to putting a preamp in between, and some of that is again is driving the impedances in a better way. Some of that can be the difference between a digital and an analog volume control.
Yeah, and this is probably not a super common setup for people, but if somebody were running like an unbalanced system mostly, and they had a passive attenuator type of volume control like that, no buffer, then you've got the problem of all that cable length kind of adding up and stacking up in a sense too. Yes. And so by the time you get to your power amplifier, you might have 10, 20 plus feet of unbalanced cable in that scenario. So that's one of those situations where having a buffer in the circuit is a benefit if you've got long runs.
Yeah, I mean, no, exactly right. You definitely especially when you have any impedance change in the system, which will happen at that passive attenuator. You have impedance changes from the input to that to the cabling heading towards the power amplifier. Yeah, it's always best to have a active circuit to then drive that change in impedance further down.
Yeah, I know guitar players run into that a lot because I've experienced that before in the past, because I know a lot of guitar players like to go for the the effect pedals that are true bypass, and subsequently they have no buffer. And so then you get a bunch of those stacked up, and then you got your 10-foot guitar cable, 15-foot guitar cable, and you've got 4 or 5 feet of patch cables, and then another 10, 15 feet to the amp. And with that high Z connection running that long, there's some pretty noticeable signal loss, and then you got to make up for it with more gain and then adding more noise. So it's a battle. Don't underestimate the buffer.
Yeah, absolutely.
Well, yeah, volume control is pretty fun. I think we do it the coolest, my opinion, but I'm allowed to say that. So yeah, I haven't experienced anything quite like it. And again, going back to that kind of one of our listening tests that we did at the beginning of the year with trying different input switching chips, that was like one of my other big recent in the last year or so of coming to Ayre major audio aha moments at just how impactful every little part in that kind of first initial stage of the signal can be, like from input stage to the rest of the circuit. I mean, yeah, everything at the front end of the source, like the closer to the source you get, the more impactful I think everything becomes, maybe.
Yeah, I'd agree with that. Yeah, the more it matters.
Yeah. Well, this is awesome. Thanks for slapping some volume control knowledge on us. And I can't remember who our viewer was that requested it, but I hope you're very happy, because it took us a while, but we finally got to it. And yeah, just keep us posted if you guys have any questions or topics or things you want us to talk about. Just throw it our way. I mean, we like to improvise and do what feels right to us on the days that we can budget the time for these things. So just the more ideas we have, the easier it makes those last minute decisions for us.
Yep, indeed. Yeah, we'll have to figure out what next. I'm going to be out of town next week, so we'll decide if we want to pre-record or.
Yeah, well, we got to do it earlier in the week, and maybe you can convince our guest that we were chatting about to join us earlier in the week. So let's try that.
All right.
Cool. Well, that's all I got. I'm going to finish my Majestic Voyage, my 9.2% IPA, and wish you all a happy weekend.
Indeed. Cheers.
Cheers.